In this lesson, we're going to talk about stoichiometry, which is the study of the relationships between amounts of reactants and products of a reaction. Now, the coefficients in your chemical equation tell us how the changes in the amounts of reactants and products are related. So if you look at this chemical equation right here, the coefficient for H2 is 1. The coefficient of O2 is not written, so it's implied to be 1. I'm sorry, the coefficient of H2 is 2. The coefficient of O2 is not written, so it's implied to be 1. And the coefficient of water is 2. What basically this tells us is that for every 2 moles of H2 that reacts, for every 2 moles that actually disappear from your reaction mixture, 1 mole of O2 will have to disappear as well, also be consumed, and those would be replaced by 2 moles of water. Okay, so that's how you would interpret these coefficients. These are the mole to mole to mole ratio of reactants and products involved in a reaction. So in other words, if you know by how much one of these reactants or products has changed in terms of moles, you can figure out the changes in the others. Okay, the amounts involved in the reaction are directly proportional. So if I know the number of moles of H2 that got consumed, take the ratio of that to the number of moles of O2 that got consumed, then that ratio is going to turn out to be 2:1, because the coefficients of H2 is 2 and the coefficient of O2 is 1. So the hydrogen to oxygen mole to mole ratio is 2:1. If that is the case, then, for example, let's say I had information about the moles of O2 that got consumed, then I can solve for moles of H2. All I have to do is multiply this reaction by moles of O2, this equation by both sides of this equation by moles of O2. So now I can solve for moles of H2. It's just moles of O2 times 2 moles of H2 over 1 mole of O2. So you can see that you can set up your proportion that way to be able to solve for the moles of the other reactants or products involved in the reaction. Let's look at an example here. Suppose you have this reaction, 2H2 gas plus O2 gas yields 2H2O liquid. How many moles of water are produced if 0.2 moles of O2 is consumed during the reaction? Well, let's see if we can do this in our heads without doing any calculation. So 2 moles of H2 would give you, O2. 1 mole of O2 would give you 2 moles of H2O, right? 1:2. So if I have 0.2 moles of O2, then that should give me twice as many moles of water, so it's going to be 0.4, right? Let's verify that. We can set it up this way. We can say moles of, you're looking for water, right? Water equals moles of what we know, which is O2, times the conversion factor, which is given by the coefficients in the balance equation, 2 waters for 1 oxygen, right? So times 2 moles of H2O over 1 mole of O2. And so to solve this problem, you just say moles of O2 is equal to 0.20 moles multiplied by 2 moles of water over 1 mole of O2. Notice that moles of O2, the unit cancels out. That gives you 0.20 times 2. That's 0.40 moles of H2O, as expected. Okay, you can see 0.4 moles. Let's look at the answer to this second question. How many moles of H2 are consumed? Well, do the same thing. Basically the same thing. You start off with what you know. You have 0.20 moles of O2 consumed, and the mole-to-mole ratio of O2 and H2 is 2 moles of H2 for 1 mole of O2. So there's 2 moles of H2 for 1 mole of O2. So you can think of this as conversion problems, just like unit conversions. You use the coefficients to set up your conversion factor. So imagine this as your conversion factor in going from moles of O2 to moles of H2. And so your answer here is going to be 0.20 times 2, which is also going to be 0.40 moles of H2 consumed. And let's see if that makes sense. Okay, 0.2, the oxygen to hydrogen ratio is 1:2. So if I lost 0.2 here, I'm going to, for oxygen, I'm going to lose twice as much for hydrogen. So I'm going to lose 0.4 for hydrogen.